Okay, here we are. We're going to look at example 5. And in example 5, I'm going to just put it here. Example 5 is talking about a cereal bar that contains 130 calories. The number of calories consumed is a function of the number B bars eaten. Will this situation represent a linear function? Okay, so let's take a look. So, does this represent a linear function? In other words, if I eat 1 bar, I'm eating how many calories? 130. If I have 2 bars, then 130 times 2, correct? And then 3 bars, 130 times 3, 4 bars, 130 times 4, and so on and so forth. So is this a linear function? As x is increasing by 1, as my bars are increasing by 1, my x's are increasing by 130. So is that a linear function? And the answer is yes, it's a linear function. It has a constant rate of change. So you want to write some type of information like that. So let's write that down. So for part A, as B increases by 1, C increases by 130. So the rate of change, okay? So those of you who like to use abbreviations, here's a good one. Rate of change is constant. So therefore it's a linear function. Okay? Now, find the domain of this function. Is this discrete or continuous? Explain. So now we're going to make an input-output chart. And if you look, does it tell you the number of bars we're eating? It doesn't, right? Now, we need to know if this is continuous or not. So can you eat a part of a bar? Yes, you can eat a part of a bar, right? So therefore, since you can eat pieces of them and you don't have to eat the whole thing, this is a continuous function. So we create an input-output chart to graph it. Now the domain of this function, I could eat 0 bars, I could eat 1/2, I could eat 1/3, I could eat 1, I could eat 28, right? So I could eat so many different amounts that I can't even list them all. So to create the domain, so this is part B, the domain for this function is going to be when B is greater than or equal to 0. The only thing I can't do is eat a negative amount of bars, okay? So that's why the domain is greater than or equal to 0. Now, the range in this is going to be unique. See, now the range can be any numbers, okay, when this is equal to 0. So when this is equal to 0, my function, how many calories are you eating? The answer is 0. So the minimum amount of calories you can eat is 0. And we can go all the way up to infinity. So you can go all the way to infinity. This is really the range of this. It didn't ask for it, but I figured I'd show you. And then in part C, you're going to graph this function. So we would create an input-output chart. So I'm going to create the input-output chart. I've got my X, I've got my Y, and then I've got my point, right? X, Y. And here I have my function, and what we're really doing is the number of bars, the calories is equal to the number of bars times 130, or 130B. Okay, so here's my input-output chart, and you would plug in numbers, 0, 1, 2, 3, 4. Remember, it goes to infinity because you can eat as many as you want. It's a continuous function, so we're just going to pick a few so we can get some numbers. So if I eat 0, I have 0 times 130, right? Which is 0. So my point 0, 0. If I eat 1, that's 130. So that is 130, and that's 1 comma 130. If I eat 2, it's 130 times 2, which is 260. So that's 2 comma 260. And so on and so forth. And you would continue to fill this in. And I'm just going to give you the endpoints here. And then you would take these points and put them on the graph. Now, because it is a continuous graph, and I'm just going to zoom in here in a second. So since this is a continuous graph, where are we? Sorry, let's zoom it out. Hold on. So since it is a continuous graph, right? Just show this to you. If we look at this graph, there's a line through it, and notice it goes on forever and ever, showing that the range is going to go up and up and up, and the x is going to go up and up and up depending on the number of bars you eat. So this is what the graph would look like for a continuous function. So if you want to just jot down that, pause the video and take a draw a little picture in your notes, that would be great. All right, you can look on to the next example.